All right, we are live. So this is part 3, and I'm trying to remember where we left off last week.
So this module, I think the one we're looking at today, should kind of prompt us with where we were. I know the last thing we did, we actually deployed the sample configuration for all of these modules essentially that we're going to use, and we got it up and running with the baked in RTSP URL. I guess that was part of that configuration.
Oh yeah, we were snooping on you. That's right.
Yes, and then we connected to an RTSP camera that was pointed over here. And this is a good segue to kind of see where we've gotten to today. So essentially, we have this solution that has been deployed that's running an object detection workload, a CustomVisionAI model that was trained against stuff that was for a particular environment, not necessarily the one we're going to look at today, but it is running. And we're going to make it our own today by delving into the art of how to customize object detection models. And we'll also look at employing an academic grade, and I guess that's a term I've coined. It's in my documentation. I say that because, this is PJ Redmond's work, the YOLO object detector, which did start out as a series of hilarious academic papers. I highly recommend anyone out there that you read them. They're rife with memes and other absurdities that you don't normally see in an academic paper. I'm not even kidding. It's a real treat to read, and you're just like, the guy that's responsible for Skynet has a sense of humor. There's something about it. So
you're gonna have to send me those. That's gonna be amusing. Oh, and one change we did make. This is why we're running a little bit late today. Is there was a little bit of lag with trying to get your video here and then processed and streamed back out. So right behind me, moments ago, I guess I can.
Moments ago, as in
Yeah.
like got delivered to you
Yeah.
moments ago.
I did get some cameras from eBay, and we just mad dash set them up.
Mad dash, like the maddest of dashes.
Yeah, so now we where we ended last week, let me switch over to the Jetson here. We had the video at Paul's house that our model was running on. Now you're looking at a camera that's pointed out of my office window running the very same model, but this is much more performant. So, and we've got another camera here over here where you can stare down at me from the heavens above.
It's actually a miracle. I think that, well, no, we knew this would work. We're professionals, right? But this was, we're going live in 30 minutes. The cameras arrived. Well, we must set them up.
I told you this, what, the last 2 streams. I love updating stuff just before I have to stream.
Well, and for the viewers out there, I hope this is a testament that, like, as you're watching this and you're thinking like, oh, I don't know if I want to like make the investment in the cameras. The time investment isn't that huge for setting these up, right? We got them in like half hour, and the cost wasn't that bad either.
Yeah, eBay, I think it was about $25 per camera, something like that. And they're actually pretty cool cameras. From the admin page from my phone, I can actually reorient the camera and look around and things like that. So yeah, I mean, for $25, it's worth playing with.
So you've got like pan, tilt, zoom, and all that good stuff, which is awesome.
Yep.
So we'll start with the module 3, which is up and running here. For those of y'all following along, at this point, it would be advisable that you've completed the earlier modules in order to get here. And at this point, just like what you're seeing with Erik's setup, you would want to have your cameras configured probably in the place that you expect them to be. And that's going to make sense in a few moments, because we're going to show you can actually use these cameras to obtain samples from the environment that they're in. So this actual environment that Erik has deployed them to create a contextually relevant training sample set for detecting object detection models.
Oh, interesting. So you basically use frames from the video to show it what an ordinary frame would look like so that you can start noticing when something else arrives.
Exactly. And it gets a little bit more meta when you consider that the thing I can think of to draw the best metaphor, and I hope people are familiar with this, how do you write a compiler, right? Like what's the code? What compiles the compiler? You start with this like primitive kind of concept of a primitive subcompiler that you use to consistently build up until you get to that. The same is kind of true with custom object models. So we can actually develop a primitive model first that maybe uses a few samples that perhaps will lend to a little bit of overlearning and overtraining. And you can actually automate those cameras to gather samples with that primitive model to do an end-to-end reiteration type of pipeline, if you will, of, okay, so I've got this model, that was trained with 15 images and it's, not always getting everything that it should. Okay, well, every time that it thinks it sees something, let's capture that as a sample. And then we'll look at it with our eyes and really train it to say like, yeah, you were right then, or you weren't right then. And then repeat the process until it gets so smart that you've built Skynet.
So this is going to be what, a 6 month straight stream?
So funny. Well, when we get there, I'll go into a bit more details. But no, I automated this thing over a weekend once and got like 6,000 images. And I think once you start with that baseline, you build your primitive model and you automate it. It's pretty accurate at that point. It'll give you some good results depending on what you get. So to start with that, the first thing we're going to do is head to a service that's offered under the cognitive services umbrella at Microsoft called CustomVisionAI. And so you should have a link there that you should be able to bring up under the module 3.1. There should be a link there to head into CustomVision.ai.
Let me. New tab.
And the other short way to get there is just CustomVision.ai. It should bring you right to it. And this is a pretty amazing tool because it makes the development and also the exporting and deployment, essentially, not the full deployment, but the packaging, at least of the model, the object detection model, relatively easy. So yeah, go ahead and hit the sign in button there, Eric, and let's see what that brings you to.
Let's do this. Let's go to my work thing, just so when it signs me in.
Oh, and I encourage you to sign in into your Microsoft account, because you might find that you might have access to projects other individuals on our team have been working on, which is kind of cool. We can use this for demonstration. See, okay. I would hope I could share mine with you. That would be cool. Oh, so yeah, you see a few. Someone's done a coronavirus mass detector and that sort of thing.
Nice.
So what we'll do, we're going to start a new project, and we're going to want to follow the exact settings that are outlined in the module. And I can sort of read those out to you. So you'll give your project a name, and I would give it something, Eric's project or something like that. I think you can actually change it later on. Now we will know who it belongs to and that sort of thing. And that's the hardest part. But I think they let you reconcile the name later. I could be wrong there. Well, if we give it something generic. And let's see. So then what you're going to do, I see you've got them side by side. You'll want to set those options. Now, while you're setting those, I'll explain them a little bit. There's an error already in that picture, by the way. So it says project types classification. That's actually an error, and I need to update that in our documentation. It should be of type object detection. I'm very sorry about that.
We're going to create a new resource group, right?
Yes.
We're not going to use somebody else's. So Eric, custom vision demo. All right.
Yes.
And that'll work. We're going to put it in my subscription. We already have a Jetson Nano resource group. We'll just throw it in there. Cognitive services, East US because it's close to me. And what pricing tier? Oh, I guess S0 is all we get.
S0. And once you get back to that screen, once you've created that resource, it's going to be a good day when we already found a issue in the documentation. So
object detection.
Yeah,
okay.
we want to. Yes. So, and that's an interesting distinction. So, classification and object detection are two different worlds or beasts, if you will. In that, an object detection model tells you where something is. So it'll tell you where and draw a bounding box around it. So it's a bit more work involved in the algorithm in order to do that. Versus classification will literally just tell you, this image. I'm not going to tell you where the cat or the dog or the person or the vehicle is, but I will tell you that it looks like something is there. Like this looks like a picture of a cat, but I won't tell you where it is.
So yeah, so here's this image, and I'm going to tell you with high likelihood, high probability what this thing might be, versus find some one of these thousands of things I'm trained to see somewhere in this image and tell me exactly where it's located.
Exactly.
That seems like a much more complex problem.
And it certainly is. It certainly is. So
which domain do we want here?
So the
Just
domain
general?
will be, yes. So that'll be the general compact.
Okay. Oops. There we go. All right. Create. Oh, wait. General compact.
General compact. Now, the reason for that is general compact will produce models that are intended to run on low resource constrained devices. So if you're doing like a general, that would run on like a T4, some data center grade GPU. We're using this NVIDIA embedded hardware, so we're going to use a compact model. Essentially, is what that's going to do. And export capabilities, basic platforms, TensorFlow, etc. Yeah, that all looks right.
All right.
And we'll continue. And I will update that documentation like immediately as soon as we get some free time after the stream. I can't believe that. Like
free time after the stream. You mean in the time you will be preparing for the stream we are doing tomorrow?
Right. That's right. We're doing a blitz of streams, so we will be alive tomorrow and Friday.
Yes.
U.S. time for you folks that may be in different time zones. Once you've created your project, I mean, it's kind of insane how easy this is. Literally, all you need to start doing to build a model, you need like two things. Well, really one thing. You need a bunch of images. And those images then need to be tagged for what the object is of interest that you want to actually identify. So let's see. That's interesting. I guess it's still spinning up, so it's still telling you loading.
I figured it. Oh, there we go.
And so that's why it's telling you. It's like add images. Yeah, that's because that's really the only thing you need. It's some images, and the images need to be tagged. So I will challenge you real quick. If you're on Windows, there's an easy way that we can get enough samples to create a model right now. It won't be a good model, but this is for the purposes of live stream. We want to show how you can develop a model.
Okay.
You need a minimum of 15 images. And the easiest way to do that, I hope you can do this, your camera's probably tied up, maybe you can't do this, is, we could turn on your webcam and use the camera app and snap 15 images of yourself. Or I could send you a bunch of images of me and you could tag those. Either or.
Yeah, so the webcam is going to be tied up. It won't allow me to do that. Had I known this beforehand, I could have set up another camera and brought it in as a USB device, and we could have used that one. But we could...
I know how we can do this.
Either that, or we could take a recording that I have of myself and strip images out of it.
Nah, I've got a way.
Right.
What we will do is we'll actually continue through the section. Now let's kind of gloss through the documentation as we do this, just to set the expectation for what we're going to do. So let's head back to that module 3 documentation. And you'll see in the example I showcase here, here's some images of myself, and there's the demonstration of us tagging the object of interest. And I do want to point out here, when you are detecting an object and how to tag, this is kind of important. Object detection models are good at detecting objects. Like, I had to beat this into my head. Like, they're not for detecting like minute details of things. Like, do I have food on my hands? That's not an object.
So this isn't which person is this? It is just, is it a person?
Is it a person? Yeah.
Gotcha.
And that should also conduct. So like the example you see of me tagging what I'm calling a person there, I'm looking at that and I'm thinking in retrospect, I'm really tagging a head. Like a person with the bounding box would also include my shoulders.
That's true.
And so hopefully we can use this as an example so you can kind of.
So just thinking about this, because we know that some surveillance systems and stuff like that, especially operated by polices and sometimes, states, do individual facial detection recognition. So do they first do a model to detect a person and then take that image and then have facial recognition run on it? So how would something like that look?
Yes. So now to my knowledge, I could be totally like smacked down here by someone who's done more experience with this, but I can tell you, in my experience with this, what you would do is, yes, you would do a cascaded inference of like, where's the person? And then within that, where's the face? And then you would use a facial detection sort of algorithm to identify who the person is. Now, what's crazy is building up those models, like to tell like who's who. They're actually they work a little bit differently. They look at, your structures of common structures. It's not an object detection algorithm when you're doing like facial recognition. It's a different type of algorithm altogether. But you're right. You can use that heuristic of find the person, now run the expensive algorithm on the face. And I say expensive, but it doesn't take much data in order to accurately represent someone's face. Simply knowing things like what's the distance of the eyes to the nose to the mouth. They use these points of interest to sort of dev those up. I'm not an expert on that, but I did work with a local startup out here called Zenus Biometrics that was doing exactly that. And they demonstrated that they could get that down to the point of, upload 5 or 10 images of yourself to their system. And they can now accurately have, an event, say like a concert, where your face is your ticket. And what I would say the limitation of that is what's the subset of how many people are attending there? And it's a little mind-blowing that it actually scales pretty far, like to thousands of individuals.
I wonder whether facial recognition would be able to tell the difference between my brother and I. We're twins.
So I think what you want to look at for those, and we are deviating a little bit into like the extremes of this, but
we are. I just mainly wanted to address sort of like, well, how is facial detection done in a live video if we're kind of choosing between, classification and object detection?
So a good way to test that is you go up against some sort of entity that is employing these types of things and see whether that hypothesis works. So I would ask you, has your family ever uploaded a picture of both of you? And what does Facebook suggest for the tag of that individual? And if you had a image of both of you in it?
Yeah, that's true. Yeah.
And does it work?
It tends to suggest the person you tag the most.
So it's cheating a little bit.
Yeah.
Heuristic. Okay.
Yeah.
It's always a heuristic.
Yeah.
So, but going through this, once you get enough images, and I think it's like 15 is the minimum, you will get a terrible model like that will work to some degree of accuracy. And then you can export it into a variety of formats. And the format we're going to look at is this format called Onyx, which stands for Open Neural Network Exchange, which is, it's an interesting format. It actually represents your model in such a way that using like what's called the Onyx Runtime is kind of how it's paired. The Onyx Runtime is special. We're not using that on these Jetson devices. We're actually using, for this instance, we're going to use an Onyx model converted to an TensorRT model, running against the TensorRT runtime. But this Onyx runtime, the way it works is really clever. It looks at the host system and can say, like, is there an FPGA here? Is there a GPU here? Or is there only a CPU here? And I will optimize the graph of that model, the convolutional neural network or whatever that makes it up, to essentially adapt to whatever is present on the host machine that's running that Onyx runtime. So it's a really cool technology if you're interested in, open standards for these types of things. I think they do it quite well.
So that had never occurred to me. So you can actually convert, and now I forget the language that it's done in, but so you could convert one of these models into an FPGA.
Yes. Now the implementations and conversions for those can be different, and I don't want to overstep, but my understanding is Onyx runtime attempts to essentially look, is there any form of acceleration here? And if there is, and it happens to be supported by the runtime, it will do what it can to essentially optimize it for the available hardware.
Well, that's just super interesting to think, like, way in the future, right? You could train a model, try it out on an FPGA, and then eventually turn it into an ASIC, right?
Yes. In fact, they kind of do that to some extent. There's been explorations into that. So,
and if you're not familiar, ASIC stands for application specific integrated circuit. I just lost my train of thoughts there. And they're actually used for a lot of things. Like if you have a cable box in your house, there is an ASIC on it that is very specific to doing the encryption and decryption.
And so the way that works is to give you the quick rundown. So GPUs accelerate because they have like SIMD operations and things like that, and special abilities to do like vector math and that sort of thing, like super duper fast. FPGAs and ASICs are very similar in that what they do, the FPGA will synthesize the chip using what's called lookup tables. They call it synthesis. It will change the chip to where it essentially behaves like an ASIC, but the performance does not match an ASIC. So if you're looking at performance of these things, ASIC is going to blow everything away, but it's also the least malleable. Like you can't change it really. FPGAs can be changed up to the maximum threshold of lookup tables that they have, and they're also extremely fast, but they're complex. There's a lot more complexity there. And then for the GPUs, you're not synthesizing anything. You're not changing anything. You have an accelerated piece of hardware that's essentially allowing you to do mathematical operations faster. So I don't know. I've always found the concept of ASICs, like you can turn a computer application into a circuit, right? It's just,
oh yeah. Well, the ASIC part of it is actually having the integrated circuit physically made, right? The FPGA is sort of the fascinating thing. Like, wait, so I have a small integrated circuit that allows me to simulate custom integrated circuits? Like, yeah, it's just super cool.
Yeah, it is insane, and unfortunately, that's not what we're talking about here. But I think it's important to cover that this where the state of the art is exactly what you're saying. And just one quick aside, because you're mentioning it. If you have an iPhone, I believe those are equipped with an FPGA, and I believe that they do things like for the video decoding and stuff like that. So you might have an FPGA in your pocket today, and you didn't know it.
Yeah, and I mean, if you're using a server in the cloud, you are probably using an FPGA. I mean, a lot of networking is going software based and FPGA based, where they implement security things implement it right there on the wire using FPGA.
We could go here. We could talk about how the ASIC miners work and stuff like that. But just know this: ASIC is super fast but can't change. FPGAs can change and they're super fast but super complex. GPUs don't change but they're super fast. There you go.
Just targeting different things.
So once you export one of these models, for us to update what we currently have running, you're actually running a model that was trained on a whole bunch of stuff at my house. So your Jetson Nano that you were showing earlier is a model that was trained on things that I had developed. As our documentation shows here, the only thing you have to do is somehow get the Onyx file and the labels.txt, which will contain the classifiers used in your labels, onto your device, and you essentially have your own custom model. It's just the time it would take for us to develop one of those on a live stream doesn't make sense. So that's why we're talking about it, if you will. But I think we can make one. And we're going to do that. We'll go to the next step, which talks about an additional module that was deployed to our device. So this will be in module 3.3 that was deployed way back on our previous episode. We didn't talk about it. So this is this thing called the CameraTaggingModule, and it is cool. It is so cool. This is that thing we were hinting at earlier that you can use to sort of gather your training samples rather easily. Now, I felt it wasn't valuable to rewrite the entire content. So you'll see there's a link there that says, like, you know, more content is included in this article. Let's go ahead and open that up, and we'll sort of follow through it a little bit. This is exhaustive. I mean, this is a whole module in itself. And we're going to quickly go through it and maybe even gather some samples from your newly connected cameras.
All right.
So if you scroll through that, you'll see, you know, that's just showing how it appears in our deployment template. You can maybe cross-reference that to the one we deployed on the last episode.
Yep. And so all this is, you know, episode 1 and 2.
And then we generate the deployment, etc. That was all done for you. Now we want to use it. So get this. This is so easy to use. It's like, this is ridiculous. I love this. Like, this was developed out of the there's a division of the IoT Edge team that focuses on custom vision workloads. A real good friend of mine, Emmanuel Bertrand, this is sort of his brainchild, and it is so easy to use, as you're going to see. So to get to it, on our Nano device that we already deployed essentially our sample suite of IoT Edge modules on, there's a module running on port 3000 of that device.
So let's switch over to that.
And you might even be able to hit it from here, from your Windows machine. If they're on the same network, you might be able to.
Oh, is it open to the public?
Not public, but it should be.
It's bound on the public interface, right?
Bound from the host to the container. Yeah. So we'll try and see if you.
Look at that.
Look at that. And it's probably going to show Big Buck Bunny because, you know, we have this tendency to put Big Buck Bunny on everything. What browser are you using by chance?
This is the new Edge.
So I want to say that it doesn't work in one of those browsers. The Edge, no, you're using the one that's built on Chromium, so it should work.
Yeah. So what is this? So it's trying to look at this live stream. I don't even know what 41 is. That's not any of my cameras.
That's an improper configuration. That's why we'll fix that in the source code. Don't worry. So if you scroll up a little bit, there is a change camera button. So we'll go ahead and set that. And you may have this on your clipboard. Use the RTSP URL to the camera in question.
Let's see. I do not have it on my clipboard, but I remember it. So here we go. It's IoT Edge rules at, and that one is 26, the outside one, the one we're playing with.
Okay, so this is the one pointed out at the street.
Yes. All right. So let's.
Then you'll add the camera. Then select it from the drop down.
Wait.
So now you'll.
Oh wait, that didn't work.
I said this was easy. I'm eating my words now.
All right.
It is easy.
Add camera.
Yeah. And then switch over and hit save. And that should switch this thing over to begin talking to your camera that you've set up.
With any luck.
With any luck.
There we go.
Ha! That was so easy. Now, you know how you get samples?
We take a bunch of pictures.
Yeah, you just hit that capture button.
You know what I could have done here? What are we tagging this with?
And I know you've got like two things open here. I guess we don't want to shrink the screen too much because I want viewers to see this. But if you control minus just to shrink this temporarily, it is rendering a little less than what I'm used to. That those buttons should be to the side of the video.
I mean,
it's okay. It's not. Yeah, you get what I'm trying to convey here. It doesn't matter.
I mean, it's at 100%.
Okay. No worries.
I think it's just the resolution because, yeah.
There we go. There we go.
The resolution because I'm showing just a portion of my screen.
It'll probably look like
that still works. Okay. So we need to tag some stuff.
So I would just call this vehicle, maybe.
Okay. Vehicle.
And then you got to give it a name. And if you do that 15 times, you would get enough images. But then we need to somehow like get them into CustomVisionAI.
Oh, we don't want. All right.
All right. So let's just take one image for now. And I'm going to show you how you can actually export these. So over there on the left-hand side, you're going to notice there is, you can see your captured images and you can see how they were tagged.
Oh, and so we could just download the ones with specific tags.
Yes, or it gets even better. So below that is an upload settings section.
Okay.
And you can, you can just throw them right into there without even having to try. Now, we set up that Blob Storage module. I don't know if you recall that on the last episode.
I do.
It's technically optional, but what that'll let you do is you can save all these to local storage or push them directly to Blob Storage. Now, you might be wondering, why would I do that? So in a enterprise grade, environment where you have closed caption TV system or whatever, that's not what I meant to say. The
closed circuit.
Closed circuit is what I meant to say. There we go. So you have closed circuit TV or whatever. Those things are usually going to run in a air-gapped network. So how the heck do you put like a solution like this into that? Using the local storage module, what you can do is put the Jetson or whatever device is running this containerized workload into that environment, and you can start grabbing images off of it to your heart's content. Then lift it out and go put it into something that has outbound network, and it will mirror them to an Azure Blob Storage.
Nice.
But we don't have to do that because now because did you push the push to local storage just now?
I did.
So because you did that, we don't have to check this, but you're welcome to. If you were to go to that Azure storage account that we created in the last video, that image is now in there.
Nice.
And I believe it deletes them once they're uploaded. So if you click back over to images right now, you're probably, maybe not.
Huh.
It's still there. So maybe it just hasn't mirrored yet. But I believe it removes. I could be wrong about that. But yeah, that image will now, because you pushed it to local and we configured it to talk to an Azure storage module, as long as it's got outbound and it sees that image, it'll put it up there for you. But we want to put this straight into CustomVisionAI. So let's head back to upload settings, and this time let's do the CustomVisionAI. And so what we're going to do is grab the endpoint and training key. And this is pretty easy to find. So if you go to your CustomVisionAI project and go to the gear icon, I believe, and that should have the settings. There's your endpoint URL, and there's your key over there under resources on the right.
And here's the point where people upload all kinds of stuff.
Mm-hmm.
All right, key.
And like I said, it's hard to convey this, but like if we had longer time to stream, like a whole day, we could totally demonstrate the whole like start with 15 images, get a basic model, and this stuff you're doing here right now. Let's check that actually worked. Let's go to your custom vision project, see if you have a training sample now.
You know what we could have done? I could have sent my kids to go run up and down the sidewalk. All right. Training images. There we go.
That's pretty magical. That worked. And now if you go back to the so here's the really crazy thing. If you go back to that article, what you just did You know how that was a manual process just now?
Mm-hmm.
Scroll down just a little bit, and there is a section in here. It's a little further down. Yeah, we did that. Go a little further down. We explain that, but we're not going to show that. The blob storage, I don't think it's. We'll go a little further down. This gets crazy. Go next section, and right there, you can automate this thing.
Oh, nice. So we just curling the camera.
So actually what it's doing is using this thing. So remember I was telling you, someone asked this question, like, why wouldn't I just use Kubernetes? And I was mentioned, I had this answer, but I was like, I don't think that the value is necessarily delivered in my explanation. I said, because the IoT Edge has these first-class SDKs and functionalities in it that really make your development life kind of easy. And sometimes you have to be creative with these. And they use this thing called a direct method. Now, what that is in a traditional sense, you would think about it like I've got a device down at the edge, and I've got it instrumented with IoT Edge, and maybe I want to, like, I don't know, trigger a method that calls, like, literally a method, like a function that's defined in code running on that device. You can use a direct method to do like a cloud to device sort of initiation of, like, turn on the light, or open the door, whatever this device happens to do. Now, this direct method functionality can also work locally if it's initiated locally. So while I'm showing you a bash script here, you could also write an IoT Edge module in C#, Java, JavaScript, any of the first class supported languages, and initiate a direct method. And this is a weird concept to think about. Earlier, we mentioned that there's these system modules, right? The Edge agent and the Edge hub, and how the Edge hub is kind of like an IoT hub that runs locally. If you initiate a direct method to a device, and that message is hit by the Edge hub and it realizes, whoa, this device is me, it won't ever hit the cloud. It'll actually go right back down to the device. So you could, in theory, develop a module that does things like, say you wanted to get better at detecting people. You can make something that says, hey, every time the DeepStream module outputs a message of, hey, I detected a person, you could have a module that says, I want you to snap an image of what you think was just a person just now and upload it directly to Blob Storage or upload it directly to CustomVisionAI. And it will use, we'll use that direct method functionality to essentially do that for you. And while you might think, because of my initial explanation, where traditionally you would like do like a cloud to device sort of scenario, you would think that, oh, doesn't that require network connectivity? No, if the Edge hub sees that the target device is the same device, it'll just deliver it to the module on that device really, really fast too, using MQTT protocol. So as soon as DeepStream says it sees a person, your module picks it up.
Nice.
So we don't necessarily have to do that, but I did want to kind of explain that here. So let's go back to our module and let's grab 15 images and let's actually generate a module. It doesn't have to, or a model. It doesn't have to be a good one, but we can get a number of samples, and you can also maybe show off your pan tilt zoom, or if we wanted, if or even if we just want to use we could switch to your other camera. It's your call here.
So I guess we need a couple more images. It probably makes sense to move the camera a bit, right? And take some more. So what do we got here? Okay, so let's pan. All right, and we'll capture again. We'll call it vehicle. All right, and save. And
we'll get some and you can take like the same image. We're just looking to get 15 right now.
Oh, is that all? That's as far as it goes.
Sorry.
Oh, wait. Now it's going. What is the deal there?
Oh, it's probably just a lag on the I've noticed that, like, when they move, this all goes back to our very first video. You're generating a lot of P frames.
Yes.
And
okay.
they're not enough to reconstruct the image. So you get a little bit of a drop there.
So let's call it vehicle 3.
This is fun, by the way.
Why is this not updating?
Oh, so there might be a bit of a lag there until it catches up, or did it disco? Maybe
Well,
if
I can see on my actual device that it has updated.
And then, yeah, I'd refresh the camera tagging module.
Yeah. Let's just see if
that should do it.
Am I just doing too much stuff? Okay.
You know, another way we could get images really fast. We could Bing image search. That's another way. There we go.
There we go. All right, capture. Yeah. We're gonna call that vehicle. What were we at? 3 before? So this is 4.
So as Eric's doing this, you can see that this is a time-consuming process, and that's why we're not going to be able to cover it in our short period of time. But one of the things that you can gather from this with models, at least in the experience I've had, there's a direct correlation to accuracy depending on a number of factors. That would include number of training images that you have. Like once you start getting into the thousands of samples, which we call, it introduces variety and variation. That is important. Also looking at environmental changes. So let's say like your camera is parked on this particular location for the duration of its deployment when you put it into production. You might want to take pictures like at night. You might also want to try taking pictures when it's raining and things like that. And so the bash script that we were looking at earlier that was doing some of that automation, that's sort of to develop that primitive model. And in fact, the way that it worked, I know we didn't dive into it, it takes images every 15 seconds. It would round robin like 4 different cameras is essentially what it does, indiscriminately taking images. And then what I ended up with, so very similar to what Eric's doing, except instead of manually capturing the images, I just woke up with 6,000 images in an Azure storage account that I then pulled down to my local box. And then I looked at which ones I thought would be good training samples. So you can think of this as, you automate it to capture indiscriminately, hopefully like over a weekend when there's going to be some variation in the weather. Include some images of the cars at night, include some images of the cars in the morning, when the neighbors are at work, when they're not at work. And all of that variation is going to give you a really, really good, contextually relevant training set for when you actually go and develop the model.
So fun fact here, I said I have a twin brother. You see the camera, right?
Does he live across the street from
you?
you?
So this is my neighbor's house. Behind it is a giant retention pond, and that house right there, backed up to the other side of it, happens to be where my twin brother lives. So
is his name Eric with a C?
What's that?
Is his name Eric too, but with a C?
It is not. It is Steve. But he is also a programmer.
Ah. So y'all could do some sort of dueling thing here, right? Like he could point his cameras at you, you could point yours at him.
We talk about setting up a long-range Wi-Fi, so in case one of our internets go out, because we happen to be on a different circuit, so often one of us will be out and not the other.
That's beautiful. So you have a family mesh net. You know what you need to do? Mirror all of y'all's data to each other. That like, in case the house burns down sort of scenario of like, oh, what happened to my backup? That's you're lucky. That's a blessing, man.
Yeah, so he moved into the neighborhood, and that's actually another subdivision next to mine. It wasn't on purpose. It was one day they were surveying the lot before the builders broke ground, and they were on the back side of the lot, and it was one of those things where is that Eric's car? And yes.
How many images are we up to so far?
I think we're on 8. I'm just trying to get the camera oriented where we kind of want it, where we see the most cars.
Got it.
Then I'm just going to take a couple more because we got kind of lagginess going on. Yeah, let's grab that one. while we're here. So this will make 8. All right. And let's. All right. We'll leave that. And then we'll just wait for this to update. Oh, we're actually lagging out on the Jetson too.
Let's even for variation, let's try to yeah, we can either turbo snap the next to get to 15.
Yeah, that's what I'm gonna do. Is I was just trying to get it to back to where we see the most things. We're most likely to see neighbors walking up and down, and flag movement, and tree movement, and things like that. Some subtle variations. All right, so vehicle, and we were 8, 9. We need to pay people for this.
I know, or we automate people.
Some mechanical Turk.
You know what's crazy? I see that Steve St. Martin, wow, is in the chat. Steve's here, actually. Your twin is watching you do this. I don't know if you know.
Is he on here?
Yeah, he's on here. Or at least someone jumped after you gave your brother's name. Nope. Someone jumped in with his name. Yeah.
No, that is him.
That is awesome. And y'all look the same too? Well, obviously we're talking about that.
Yeah. I mean, now that we're older, there's definitely variations.
One of the guys on our team, I think you were on the call yesterday, wants to develop a object detector to distinguish his 2 cats that also happen to be like twin brothers. And it's funny, like his use case is one of the cats eats too much, and he wants to make sure that the automated feeder doesn't feed the fat cat.
Which is absolutely hilarious. Okay, so we've got 15, and I guess we need to go into our upload settings. Oh, we have to. Oh, did it save it for me? Sweet. All right.
And this will be a bad model. I'm telling you, 15 samples is not enough. You want to get to like the hundreds.
Yeah, what I would probably do personally is just like record for a whole day and then send that all up. Okay, so that's all pushed.
Custom Vision, and you should, we'll refresh, make sure those images are getting up there. And let's start tagging some. I'm sure the rest are coming. I know there's not 15 yet. The rest are probably coming. Now, tagging is super easy. And like I said, the art to this that I found is when you realize, again, that it's an object detector, right? It's not a, it's not a pose detector. Have I fallen and broken my hip, right? Like, so this type of model is good at detecting the thing. So you would go in here and draw a box around the cars.
Did we not get enough? I'm talking to myself here to see whether to. There's 3, 1, 2, 3, 4. That's 12, 13, 14. So we are missing 1, right?
Okay.
So you said we need a minimum of 15?
15 to generate, yeah.
All right.
And I guess for time purposes, let's just quickly show a tag, and then we'll maybe try to export a model.
Okay.
But this, for those of y'all watching, this is not best practice. What we're doing right here is just more, hopefully, giving you the taste of the tool to know that, yes, you can use this to facilitate the development of these models. And there you go. It's so easy. You don't even have to. In fact, sometimes the thing will know, I don't know how it works. I've said, I've sometimes wonder, if it can tell objects, or if I don't know if the model's training itself as you're tagging things. But you notice it's auto boxing them for you.
Yeah, that's pretty cool.
You don't even have to try, which is crazy.
It might be differences, right? It can detect this area is different than its surroundings, and it gives you a box for that.
And you can customize the box. And while you're doing that, I'll just mention.
Yeah, because can we?
Oh, go ahead. Sorry.
House.
Yes. You could do that. Yes.
All right. So yeah.
and you think like how many messages is that going to produce on the deep stream side? Probably tons. If you did build a model for detecting houses and vehicles, pointing out your window, there's going to be a message like every second. But if you recall, we use that stream analytics job, so we're actually throttling the message output to once every 15 seconds. It will summarize them. So that's been accounted for.
I just called that a house.
But you can see here, and one of the things to consider too, Ari Bernstein gave me some really good advice about best practices for tagging. Always make sure you have the whole object included in the tag, because it treats everything outside of it as a negative. So all the space that isn't tagged is technically a negative training sample. So the fact that you did train a house but you didn't tag all the houses is actually not good, because you're saying like, yeah, and that's okay. That's okay. We're learning here, and I think that's the purpose. I don't want to.
Yeah, I guess that's something I hadn't considered. That now it might confuse, like, what makes this a house? Is it this emblem here? Because it has similarities with this over here. So what's different?
Right, and I guess like the value at the end of the day is like, I hope you're like, the more mistakes we make, I hope the more mistakes you can avoid making, all of the viewers out there, because it's real. Like you might naively think that you can just come in here and start being an artist and saying what you think an object is, but there's actually some consequences based on what you decide.
All right, so like even here, right? So I just have the back side of that vehicle, right?
Right.
And here, same thing. I really should probably stretch that so that it includes the entire truck, right?
Exactly. Yep.
Okay, that makes sense.
So yeah, what you're building here, and
so
just for the viewers out there, it's going to be a bad model. This is going to be a very, very bad model.
So Steve actually pointed out what the box stuff is. He said, I thought these typically use edge detection and entropy to find things of interest. So likely the boxes are just being drawn around those types of things.
Seems like it. Maybe it looks at like where your mouse is hovering as some sort of I don't know, center of mass. I don't know. I'm only guessing. Steve probably knows more here.
Well, you see like all of these, the trees here kind of create one color, right? So that makes some really hard edges. So,
I guess the takeaway is like, we have these tools that make it so, well, we've gotten to the point we could set up a camera in 30 minutes to throw a GPU accelerated object detection algorithm at it by simply wielding a text editor. And now you're seeing that simply by uploading images and clicking to tag boxes on things, we can get an object detection model. So it's like, it's not lowering the bar. I know some data scientists out there might be looking at this and they're like, why? We're actually making this stuff really accessible. Is kind of the way I look at it. Is like, I mean, like Eric, I think one of your kids could pull this off at a science fair project, like totally.
Yeah. I mean, I think you totally could. Like, this is significantly more approachable than I probably assumed it would be.
So let's, I think as long as
we should teach one of my kids to do this and make them sit here and tag everything.
So I think one thing that's going to knock you out too is I don't think you're going to have enough samples to train, because you're also going to need 15 images of houses. And I don't know that we were tagging them.
Which one did we tag the house then? That's an easy enough thing to fix. House. Gone. Because I only did it in one, because then you corrected me. So it won't. Wait,
but no, this is good stuff. So let's see. What happens when you attempt to train this?
Is that the get started?
So over there where it says train, up in the top right.
Okay.
Should. Yeah, and you'll do quick training.
All right.
Can't train yet.
We need to have 15. How many do we have? Maybe.
Oh, we have like
11.
Let's yeah, we'll grab 4 more. Super quick.
All right, how many do I have in here? Wait. Yeah, so we should have enough. 3, 6, 9, 12, 13, 14. There's 14 here. So we do need one more here. So let's just go ahead and capture that. I have no idea which one we are missing. Let's just go through the list. It's just going to yell at me. So already exists.
Already exists.
Already exists. We skipped one. Well, let's try 15 first. Nope. Backwards. Where's the binary search?
Yeah, at this point we're just messing with.
Oh, there we go.
To get them all in. Yeah,
we found it. Okay,
cool.
So that's that. So now we just have to figure out why we don't have all of them here.
Let's try re-kicking off that upload and see what happens.
Oh, we've got cars driving by and we missed it.
That's why that indiscriminate, like, just snap every 15 seconds. I got crazy stuff when I did it. I got the mailman. I got the garbage truck.
That just would have been perfect, though, because we would have been able to, like, capture a new vehicle on the street, which is one of the things that we're probably the most interested in.
Right. Something it hasn't seen before.
Okay. So, yeah, like, my neighbor's cars are, like, always in the driveway. Okay.
And so...
so we have 12 in here now. So where are the rest of them?
It might see some of those as duplicates. So it'll actually do an MD5. If you did accidentally save one as the same, it knows. You can't outsmart it.
Okay, so we need to make an adjustment because we need, what, three more unique ones?
Yeah, we can get those from Bing. They don't have, and that's the thing, when you're training the model, while it helps to get them from the contextual environment, they don't have to be from there. So we could get some random car images as well. However, for purposes of time, let's see. Let's do a quick example. I wonder if you don't already have access to a project that might be ready to let you generate, and if not, I might be able to invite you to one. So yeah, you had the corona mass detector. Coronavirus detector. Let's open that project, and we'll export one from there. Just for time purposes, apologies. Okay. So yeah, go to the corona mass detector, and you'll see some variation here on this mass. And if you select train, quick training, is this one also not happening?
Nothing has changed.
Oh, nothing has changed since previous training. That's okay. So what would happen is that would take a bit of time to actually generate the model. It might take a few minutes. So that's okay. Let's go to performance, and you'll see the end result.
Steve's volunteering for the next time to drive by my house so I can take pictures.
Oh, you're so lucky. My girlfriend, during the period where I was gathering samples, honey, can you go walk outside? Honey, can you swim in the pool? Honey, yeah,
I could send the kids outside too.
So, so if you click on performance there, next to training image, yeah, up at the top, near
performance. Okay.
So this is what it would look like after it's done going through the training step, and you can click export over there on the. It's up at the top, and select Onyx model, then click the download button, and that will get you your model. Now, we're not going to do this, but if we head back to the module instructions, I believe that was in section 3.2. We show you how to take that model and essentially wget it, like pull it down from that URL and get it onto your Nano. We're not going to do that, though, because your model would be bad with the samples we gathered. It really would. But
insulting me already. I don't know whether I want to finish this series.
Oh, Paul. No, it's not that. The result that you would see would I think not be really favorable for the viewers today. It would be all over the place, calling plants vehicles and things like that. You don't want that. But that's the process that we'll go through now. And again, it's not your technique. It's really just the more these things take time. So I hope that didn't come off.
Yeah, no, I'm just joking with you. Yeah, you need a lot of information to train a model.
So what we can do, though, we'll go into a little more detail on how this works under the hood, and we're going to throw an academic grade TM model at your video camera that you just set up. And my gosh, I don't know if anyone's going to ever appreciate how much, like how we're like compressing a whole year's worth of college into this hour and a half episode. So the module parsers, I want to talk about this for a little bit, but not go into super detail. So the reason why we can convert that Onyx model, remember we were talking about Onyx, can use that Onyx runtime, but we're not using Onyx runtime. We're actually using TensorRT in this particular implementation. There is a parser that we actually build on the device, and that is located in that long URL. So where it says the CustomVisionAI YOLO Parser can be found at. If you want, you can bring that up on the Jetson device in that directory.
Are we just doing terminal?
Yes, yes. And you'll see the instructions for how we compile that parser and how it actually works. Now, this is what, when DeepStream kicks off, it's going to use that parser to parse the Onyx file into a TensorRT engine at runtime. And you can see that there. And I've included a little make file in there too if you needed to build this from source, which is common when you have like a new Jetpack version. That would be a time period where you might want to use that.
Also, do we need to recompile it now, or is the shared object up to date?
No, okay. The one that's packaged will work. This is more of an FYI type of thing. And we're not going to do it here, but there's also things you can modify in that CPP file that's included there to tweak like the accuracy and stuff that this model would perform at. To give you the short version of YOLO, because we are about to use like the academic version of it. To give you a short version of it, there are two parameters of very high interest. That is the I got to look at my notes here. That is the precision, essentially, that it uses before it decides to consider an object like actually found. So there's the probability threshold. And there's also this thing called the KNMS threshold, which stands for non-maximal suppression threshold. In short, the way YOLO works, and this is a terrible explanation, but it is explained in a linked article in way more detail. It will look at something and it'll say, what is the probability that that is one of these object detectors that I've been trained to find? So, you know, is it a vehicle or a house or whatever in our model? And the KNMS suppression threshold is essentially for when you have bounding box, like multiple bounding boxes for a single object. When does it throw one of those out? And it does that because if you don't tune the non-maximal suppression threshold, it might think that you see two vehicles when there's in fact one. And then finally, the confidence threshold is that once it's kicked out the non-maximal suppression threshold candidates, that last result of the confidence threshold, you're saying like, you know, I want these to be, you know, 30% or 40% or something like that. And that determines whether it actually considers it a detection or not. It is binary at that point. It is yes or no. And then DeepStream will create a message saying that, yep, that was an object. And if you go back to that section, that 3.4 that we were just looking at, there is a similar parser that's used for the academic models. So this is the Custom Yolo Parser. And you could, if you were wanting to train a model against the academic grade parser, you could totally do that. You can. Now, the difference between these two, CustomVisionAI is technically what's called a YoloV3 Tiny model. Tiny indicating that it runs on a resource-constrained device. We're going to look at, for custom YOLO, we're going to look at YoloV3 and its YoloV3 Tiny variant. Because you're using a nano device, we're going to want to use YoloV3 Tiny. And so the same thing I just explained, there's some minor differences are explained in that module 3.5. But just given time, adjusting for time here, I think what we're going to do is jump right into using one of these YoloV3 configurations with the camera that you have set up today.
Okay, and so the tiny versions, do we get less accuracy?
Yes, to an extent, yes. Because it's going to use less resources, it's going to not be as good at detecting objects, but I think you'll be pleasantly surprised with what it can do.
Okay.
Given that limitation. And we've got a couple instances. What I like is you have a couple cameras. We've got one pointed out at your street, and we've also got one pointed at you.
We do.
And YOLO by default totally detects people and it detects vehicles. In fact, it can even go down to saying, like, is it a car, truck, boat? You're in Florida, you're going to see boats going by.
And gators.
And you need to know, it detects weird animals too. In fact, I think if you look at the labels.txt file for it, which is included somewhere in the source code, I don't want to derail us just yet.
I was just in the mountains in Tennessee. It would have been cool to put one out and have it detect like bear or the deer that would come up and eat stuff out of the yard.
I'll send you a link to the labels.txt real quick so we can look. It's kind of nuts, like what it can do. And it, of course, if you're doing this with YoloV3, it'll do this stuff even better. So here it is. NST in Slack. There we go. It'll be on its way to you. And yeah, I've got it up already, so I'll just start kind of looking at this, like person, bike, car, motorcycle, airplane, bus, train, truck, boat, traffic light, fire hydrant, stop sign, parking meter, bench, bird, dog, horse, sheep, cow, elephant, bear, zebra,
Frisbee.
Yeah, it's crazy. And that's half of them. There's 80 total. And they're
giraffe. I don't think we're going to see one of those out front.
It may inaccurately pick one up. It's possible.
Mailbox is giraffe.
We had some fun. I was demonstrating full YoloV3 running on the heavier Jetson Xavier at Ignite last year. And some of the attendees were wise enough to be like, really, it can detect a giraffe? So they would print out a picture of a giraffe. And sure enough, it's like, yeah, that's a giraffe. So it works, but to some degree of accuracy. I mean, you're going to be surprised. It may not be perfect. So I'll just give you that disclaimer here. I don't know what this is going to do, but it's going to be fun. So to switch over to that model, what we're going to do, there's some default deployments that already leverage the ability to use this model. And so to do that, what you can do is open up VS Code on your side. And let's see. Sorry, I've lost your screen on my side. Here we go. Okay, so you're in your project. Let's go to your deployment template.json. We're going to change that to instead use, I think you're going to scroll up a little bit for this one. To instead of using dsconfig CustomVisionAI, you're going to use dsconfig-YoloV3 Tiny.txt. And I will send you that in the chat.
YoloV3.
Or you can even pull it out of the article.
Oh yeah. Let's see.
And that's almost enough. There's a couple things you're going to have to change, Eric. So that will switch it to use YoloV3 Tiny. The only other problem is we need to update your configuration, or that configuration, to use your cameras. And this is not a simple copy paste. Like, we can't just rename one. There's actually, like, they're totally different files. So
all right, so this is, let's just cd into services, DeepStream configs. All right, so I was using this dsconfig custom vision.
Yep, and we'll just grab out your video. So for folks out there, if you had developed this so far and you were like, I want to try the academic grade model, go in and take all your customizations from the custom vision file.
Oh, I was right. It is capitalized.
Oh,
so we're gonna want to fix that. So.
Oh, sorry. Yeah, I thought it sent you that in the chat. Sorry.
Tiny. Oh yeah, I've got Slack like way over there.
And that looks right. Is that all one word? Yeah, YoloV3.
Yeah.
Cool.
Okay, so yep. So now we'll just copy over.
So for those of you out there, what he's going to do is take the configuration of the cameras that DeepStream configuration, the custom vision one was looking at, and he's going to change those to instead use the YOLO configuration, because there's some significant differences in there.
Yeah, so I have a couple of cameras here. One is like a public URL to just traffic. One is the one that's pointed at me. We have all of these commented out, and this is the one that we've been looking at that's pointing out at the street. So
now, the crazy thing here is I think all we have to do now is update your deployment. So we need to redeploy to your device, and it might just work. It might wake back up, literally start running the YoloV3 Tiny workload against your camera.
Wait, this is Generate IoT Edge Deployment Manifest?
Yep.
I'm trying to remember to see whether...
Yep. And
I do not want to take a survey.
I think this is explained in the module instructions as well, just in case anyone's wondering.
And then after that, we click Run Up.
Creates for single device.
Right. There we go.
You're like a pro, man. How many hours have you logged on this? It's crazy.
How many hours have we been doing this? What, 3, 4?
So you're like, yeah. Let's add an extra one because we do a little behind the scenes. Not much though. I mean,
yeah.
Let's say you've logged 4 hours on this total. And it's like,
and I have not messed with any of our IoT products, and I have not messed with machine learning ever. So you get to learn with me.
Now, what we'll do, it's not a bad idea to watch.
Let's switch over. So the one video did die. It closed it, so now we're just waiting for it to restart.
Yes, and let's do a Docker logs on that. You'll actually see it generate the engine for the YoloV3 Tiny, which will probably take a little while on this device. Not like all day or anything.
Trying to remember.
In capital N tab should get it. Oh, sorry. So not dash in.
Oh, yeah. Oops. Video.
And it's looking like it. What's the error?
Failed to create pipeline pause config file.
Config file path / data config failed. Failed to create in VDS. Did we run did you pull from master? I know there was a path error.
Oh yeah, I mean the project is updated. This was CD data.
Okay. Let's see. So it's telling you config file path. There's some sort of error there. It says config file path / data. Can you see if that very last thing before it says disconnecting Azure? See if that file exists. That config infer primary YoloV3, all that. Yeah.
Yeah. Let's copy that. Copy as HTML. Nope. We didn't error out, so.
Okay, so that is good.
So that's there.
Okay.
What was our error? Error. So it's telling us to check the config file settings.
That one doesn't exist. .. / YoloV3. I forgot to tell you the most important part. You have to download the weights files. Man, I'm a dummy.
Oh, I remember seeing that. So let's go back to the
I'm sorry. Here. I was rushing and didn't read our own instructions, but now you know. I like.
Yeah, I don't mind failures because oftentimes if we make the mistake, somebody else is going to make the mistake, and then they have no clue what to look for.
And we get to talk about how cool PJ Ready is, because this is going to take a little while to download on your device. So we'll do that while it's running. So head back up to module 3.6.
All right.
And we'll do this on the Jetson. So yeah, you'll notice there's a script that we need to run. That is because in order to run the academic version of YoloV3, you have to pull down these weights files that are essentially the representations of the end result of training this model that contains these 80 objects. And it also has this config file that's associated with those as well. To save you a little bit of time, Eric, we can modify that file to not download the full YoloV3 weights, because we're not going to use those and only the tiny.
I mean, we got 4 minutes. I've got a 500 meg connection, so
yeah, we'll wait. So while that's happening, let's talk about how cool YoloV3 is, because I don't think we've given this enough of a spotlight. So that's running, that's pulling down the weights, and stuff should work when that's done. So head over to your favorite search engine and type in just YoloV3. Hit the first result.
And also, I'm a bit curious what the weights are. Like, how does that differ from the model itself?
So the weights are the model, essentially. That's why it's so huge for that YoloV3. That's just what they essentially call it. Now, of course, we could go into more details on what that exactly is. I might not necessarily know. So we can gloss the... So just look at this. I mean, this is just this website. It just cracks me up, right? Like YoloV3 object detection. And it's got the cool 80s.
Say YOLO again.
The fact it's called YOLO is hilarious. Like when this algorithm dropped initially, it was at the high point of the YOLO term being coined. So it's just like the perfect synthesis of, someone develops this algorithm that's going to essentially be the genesis of Skynet, and the term YOLO is coined, decides to call the algorithm YOLO. I love it. So you'll see there, it talks about like the performance on the COCO data set and stuff like that. That's giving you some overview of how this model will perform. So that map, you might have actually noticed that earlier when we were training the model in CustomVisionAI. That actually stands for mean average precision. So it's essentially tells you the overall performance that your detector will have across all tags that it has been trained on. So this is saying, like, this model has like a 50% accuracy on those models, which is actually pretty high. That's given anything in the COCO data set, which is basically what they call it, COCO train val. Again, academic papers will often cite that as the data set used to test the accuracy of a model. And you can see here how it compares as well to other models as well. So there's the like the SSD, MobileNet, and all this sort of stuff is also captured here. Not MobileNet, it's got RetinaNet, SSD 321, SSD 513. And you can see YoloV3 is actually pretty good. The one we're running, you'll notice you were asking about the, does the accuracy drop? Between YoloV3, it averages at around 50% with the top out. If you use something called YoloV3 SPP, it goes to 60%. And YoloV3 Tiny is about half that at 33. So that's, to answer that question, like how much precision do you lose? You lose about half. But it's still pretty.
But I mean, sometimes it's good enough, right?
Right.
We're not. I mean, I would imagine you would want a really well-trained model if you're talking about recognizing flaws in a manufacturing like kind of chain, right? But if you just want to know if people are walking by your house, I mean, how critical is it?
Right. So it all comes down to, like, what has the set been exposed to, right? And there is obviously, when you're looking at COCO data set, there will be, models could be unfavorably tuned to that data set. Similarly, when you're looking at things that, if an object detector is looking at things it's never seen before, personally, I find it fascinating that it can ever pull anything out of those, and it can. So there's ways to beat that. You can overtrain your model, which is actually a negative term. You don't want to overtrain or overlearn your model where it learns something so well that, it's actually inaccurate.
Because they can only identify exactly what it has seen and not variations of what it has seen.
And so you'll find these weird situations where, like, maybe, when it's detecting an anomaly on an assembly line, it does that really well. But you take that same algorithm and you point it out to your window at your street, kind of like what we're doing right now, and it'll start detecting things. But it's like, that's not what you're yeah. So it depends.
All right, so we are downloaded.
So let's do a Docker restart on that NVIDIA DeepStream module, and it should wake up now appropriately. And we'll also watch it in the logs.
Oh, let me switch. I'll switch back over to here so that we can see it pop up. I keep wanting to use my mouse and keyboard from my desktop on the Jetson.
I know. You could use something like Synergy. You can actually,
which I used to use quite a bit. There we go.
Oh yes, baby, it's working. So this is it, transforming that into the academic representation to run on the TensorRT engine. And behind the scenes, it's using that YOLO parser that we totally didn't go into enough detail on, partially because it's complex. We're running out of time, and I might not be able to answer all the questions that might pop up if they start coming. So bullet dodged. But this is going to be fun. So this should spin up. And you might notice it's actually going to start seeing those cars out your window. It'll certainly see you.
Is this sort of delay here just because it's kind of setting some stuff up? Is this a one-time hit we take, or is this kind of expected every time it boots up?
It is a one-time hit when it generates the engine. I know we're not actually reading those instructions as we're going through this. It's kind of explained there, but it is a one-time hit. And on subsequent executions, it'll be really, really fast. But like right now, you're building that engine, and you're building it on the Nano embedded device. So it's having a little bit of, it's doing a workout right now.
So we're effectively compiling something right now.
You could say that, yes. You're doing a lot of work preparing the TensorRT engine.
Why are we doing that on that machine? My desktop has 2 CPUs and 128 gigs of RAM.
Because in order to do this, you'd have to compile that parser. Not only that, the actual engine that's converting it right now to run on your machine, and cross-target the ARM architecture that this runs on. So,
oh, that's easy. Yeah.
the make file involved for that scares me. So no, don't do it.
Yeah, cross-compiling for different architectures still like.
So now it's built it's created the network, the neural network that is behind YOLO, which technically goes by a name Darknet, but I don't know if we're officially using Darknet at this point. Perhaps. I don't know. I don't know what DeepStream's really doing behind the scenes there when it says building YOLO network. But now it's doing the final step of taking that neural network, converting that to be the TensorRT engine, and we're going to start seeing results here. Yes.
Yep. Build complete.
And now we get to play with it with your various input sources.
Oh, look at that.
Get the sheriff. Get the sheriff. Get the sheriff. Yes, it got the sheriff. Yeah.
Did it say sheriff?
No, it said vehicle or car.
Oh, okay. But I mean, that's perfect. I mean, because we do have new information too, right? Because I don't think I don't think that this car here was there before, and it kind of kicked on right as that sheriff. So is this taking pictures right now, or is it just live?
So it's live. It is grabbing a frame from your RTSP camera.
Oh, what I meant is we talked about kind of saying, oh, I saw a car, I'm going to take a picture so that we could use that for subsequent training.
Oh, no. So once the model is enacted, it's not learning from itself. That would be sweet if you could do that, but it is not learning from itself at this point. It is just running that model as is and performing the detections as they happen.
Oh, wow. There we go. So that sheriff should drive back through too, because this is a cul-de-sac and they just do kind of patrols around here. So we should see
That was pretty awesome that it like got him driving by.
Yeah, and kind of tracked it.
I would try moving your camera. Let's. Oh, and now it's getting the other truck there. And it's going to depend on like what it sees, like how good the vision is. You know, its field of view. Because you notice you're not getting anything right now. I don't know if the viewers can see that screen, but let's move the camera over a little bit to another position where you don't have like maybe the reflection coming back.
Yeah. Is it moving? Some delays. Oh wow! I just saw a car drive by. Like
car.
That was fast.
A little bit of frames, but that's okay.
All right, let's see. So we're.
Go send the kids out in the street. Well, not in the street. I'm sorry, in the driveway. We want to be safe.
Oh yeah, I can see the camera's own reflection in the window right now.
Nice.
It looks like we're delayed on DeepStream though, because I've completely moved where the camera's. There we go.
Okay, now it's picking it up. So you'll see it like depends on where we're pointing it. I know, and I could tell you like again with like YoloV3, it's pretty accurate. So yeah, we'll see. Push it over a little bit to the right there and see if that fixes it. But as you can see, there's some trial and error here. If you do have one of the higher end models and you're viewing this with us, you could run full on YoloV3 and it'll be of higher accuracy. So yeah, we're getting one of the vehicles over there. And you'll see that example I'm showing you right there of it actually sees the one vehicle as two. That would be that NMS threshold that you could use to tweak that out. And we could tweak this. That's explained in the details, but I mean we're kind of flying by the seat of our pants here with this.
Yeah. I just sent a text. I don't know whether they will get it, but we'll see if a child will run behind the truck.
Oh god.
See if it ends up. Nope, I just saw a car.
So let's.
Whoa! I saw it on DeepStream before I did on the admin page. So the admin is actually more delayed.
Nice. And you might get better frames if you close. Don't close it, but I'm just saying you might just notice on your personal testing. And the other thing we could test too is we could switch to your cam, the one that's pointed at you, and make sure it detects a person. We also you might find it. We could also hold up some objects to it in your office.
Oh, it went green, but you can see.
Oh, I see him. I see a junior down there, and it picked him out.
What's that?
I saw it picked out a child behind the vehicle.
Yeah, I don't know how many of them are out there. Oh, there's another one. It's lagging.
So there's some tweaks we could do here, of course, but you get the idea.
Yeah, no, this is fun. All right, so now we want to switch to
yeah, let's switch to your camera, and then we can do some fun things like hold stuff up and things like that.
Okay, so we need to modify this.
And so we're now using the YoloV3 Tiny config.
Yeah, so YOLO. Oh no, we're not in this directory. We need to go to
DeepStream. And you notice it's not picking out all the cars. That's it's not perfect, but you can also do something called transfer learning, where you can start from an existing model like this one, and then show it new samples, that you've perhaps gathered with the CameraTaggingModule, and you can almost weld them together. It's called transfer learning, and get it to more accurately detect everything. Oh, there we go. We've got another kid in view. That's
so
awesome.
Now we need to restart NVIDIA DeepStream, right?
Yeah, and it should be super fast this time. So okay. Did we switch? Which one did we switch to? The office? I know there was the highway. We don't want to do the highway.
I'm pretty sure I switched to the office.
Okay.
We're gonna find out.
So the uptime now, you're not going to take that same performance hit as before. Yeah. One thing to be aware of, if you do notice that you're constantly hitting that performance hit, like you're developing this on your own, you're somehow straying from this this nice happy path of a solution I provided here, you might find that what DeepStream does, it looks in a very specific path for that file, and if it doesn't exist, it will drop it in the current working directory. And even though it's created the engine file, if it's not in the file you specify, in the path you specified in the config, it'll just keep regenerating it. That's not going to happen to us, but I'm just telling you, it's happened to me before. It's not fun. So yeah, it's like it's already through the building of the network, and it should come up here in much less time. And what's cool here too, like all of this is now standing under IoT Edge. So you've got this thing that's monitoring this, making sure that workload's always running. And you'll find that out over time, Eric. Like, 'cause I'm sure you're going to leave this on for a week. See
yeah, I've turned it off after the stream and stuff like that, and then started it back up, and boom, video hits the screen.
It's one of the things, like, in our line of work, we do a lot of demos. And IoT demos have always been the bane of my existence. Like, how do I connect this damn thing to the internet? IoT Edge demos, on the other hand, are awesome because they always work and they don't even need internet, which is great. So you're seeing that in real time here. So that should spin. And it's that when it's building the engine, that is the part where it's actually saturating the GPU core. So you'll notice it's not rebuilding the network. That's the part that took a long time.
Okay.
Yeah. And the beefier devices can do this engine piece quite fast, like quite a bit faster. In fact,
I was so tempted to order one of the expensive ones too. I was this close.
And I'm hoping that path is right. I mean, it should have started by now. That's why I'm wondering if I shouldn't double check that path. Let me look at the source code of what I sent you in that config. Maybe
Well, this is also the camera that is on the different port, and it required different. When we looked at it through VLC, it's right. So
let's see. No, that directory should be right.
24. Let's take a look at. Yep, there's me. Oh, there we go.
Oh yeah. Is it up? Is it up? Yay!
There we go. I hear an echo. Look at that.
So yeah, seeing your monitors, I wonder what it thinks those two boxes are, the camera boxes.
Yeah, me too.
So it sees you rather accurately.
Let's see. Oh, we're lagging a little bit because there we go. I'm holding the box.
Oh, hold up that bottle. It's pretty good at that. Your water bottle. It can usually detect those. Usually. Oh yeah, there's a bit of a lag. That's okay.
Yeah, we're lagging a little bit.
And for the viewers out there, part of the reason why that is, and I do this at home too. All my cameras run on Wi-Fi, and you want to like tune that thing if you're going to do it that way. Ideally, you would run these over Ethernet, and you would notice way smoother performance.
I actually could have plugged that one in. It's sitting in front of a switch. I should have plugged that one in that way.
See, I'm seeing a few for TV monitor, and yeah, it definitely sees your monitor. Laptop, it knows that's a laptop, dude. That's bizarre.
What about?
There might be enough differentiation with the bottle. And the YOLO object detection algorithm, it depends.
What does it think this thing is?
There's so many things to try here.
Yeah, I think that I think there's too much changing in the picture, which is why we're getting so much lag.
But what we do have, and this is a good stopping point. I think like what we've done here though is we've kind of shown you don't want to take the time to build a model. You can try something out the box and it'll work to varying degrees. We've shown you some tricks on how you can do a custom model. What I like about this model is it produces a lot of data, and that's going to be really good for the modules that we're planning to record in the future. So when we do time series insights and stuff like that, it's going to be really nice to have a whole bunch of data, and we can always come back and sort of tweak this further. But I don't know. Like I know that I like this is like the ultimate nerd snipe. It's like, Eric, I've lent you the information on how to detect objects with a camera that you can place anywhere. What are
Yeah,
you going to do next?
yeah.
I'm sure.
This is gonna be fun.
Like, I won't be surprised tomorrow during our allotted time for recording that you'll be like, I can't do it. I actually didn't go to bed last night.
Yeah, that's gonna be tricky because you start getting so many ideas for stuff, and I'm gonna have to train. I'm gonna have to train it to see stuff. Like I'm quite bothered by the fact that it did not detect my super old voltmeter over here. Did you see that?
Yeah. Well, and that's where transfer learning can come in. We need to tell it like that's a voltmeter.
And a very old one.
Now, the full-on YoloV3, I'm not even kidding you, would probably detect all your screens, it might even be able to detect the keyboards and everything. It's startling. Like when I first got the Xavier line and pointed it, like, it is startling the difference. So yes, the Nano's cool. It packs a powerful punch, but it is the entry level. I do want to mention that. It is a tenth of what the production grade stuff does in terms of power.
So, question is the reason that it's struggling to keep up, is that the frame rate from the camera itself, or is that really just because you got to figure I'm moving, reflections, sun, you've got the TV, there's a lot changing in frames. Is it just not able to keep up?
The biggest bottleneck is because we're grabbing frames over Wi-Fi. That is the biggest. That's like the number one. If you plug this into an Ethernet switch, you would find significant performance improvement. The second,
yeah, because we've got Wi-Fi both, right? The camera is Wi-Fi and the Jetson is also Wi-Fi.
yes, and in fact, if you put one of those on Ethernet, you'd notice significant improvement. Even just one of them. So even if it's just the Nano goes into Ethernet, you'd be startled. Like it won't choke nearly as much.
And we can do that for the next stream too. I can plug all the stuff in.
That's number one, and then it's easy for me to say call out number two, which is there's some resource contention based on us using the entry level device. I realize now I'm selling everybody on the Xavier line, and that's okay. But that would be the second explanation. But number one is definitely Ethernet. In fact, all of my devices that I run at home, my Jetson devices are all on Ethernet. I won't let them run on network or Wi-Fi after exhaustive experimentation.
Yeah, I've got like a pile of stuff over here. It was less cables to put it on Wi-Fi. You could see all of the, I guess I don't have it on stream now. You can see it because you're looking at it, but I've got like all the secondary keyboards and mouse and everything already. That's another thing with IoT. You cannot have a clean desk. You can't. It's impossible.
No. In fact, that's why I only stream with the top half of my body showing, because I'm actually in a junkyard pit of IoT devices. You just can't see it.
We should
have your overhead cam. Like, did you have to sweep yours under the desk? You might not be as bad as I am.
Let's let me see if I can switch back here really quick.
But it's good at detecting people. I mean, it hasn't really lost you.
I'm gonna switch back to the other device because I just realized like people are outside doing stuff. The girls are riding around a little mini car.
Oh yeah, let's throw it up again. And once it comes up, we can use that as the outro. I apologize. I booked a meeting next to all this fun. Just terrible idea.
No, it's actually a really good idea because I think that we would end up just doing this stuff forever.
Let me stop talking. So I'm wondering about this because that building the tensor, maybe I want to blame the Nano again. I'm pretty sure maybe no. Yeah, I built the network already. So I guess it just takes this long. So yeah, but in conclusion, like what we did today, I mean, dude, we talked about a lot of stuff.
Yeah, we went over a lot of stuff.
So if we were to like review the module stuff, we showed how to build a custom model. We showed how to export that model. Although we didn't export and use a model, I think it's pretty straightforward how you would do that. We literally just drop the .onyx and label.txt file that would come out of that exported file. We showed how to use the camera tagging module. In fact, we used it enough to show you how you can upload into all of those services. We talked about the YOLO Parser, which that's a deep dive in itself. I mean, it's included there for completeness, but I don't think it's something we would necessarily get a lot of value diving into given our time. And now we've got an academic grade model running against a random neighborhood in Florida, in good old Land O'Lakes.
Which is not where the butter comes from.
You know, I was walking with my girlfriend today, and she says, well, isn't Erik in Australia? I'm like, no, he's in Florida. He's in the place where John Cena lives, Land O'Lakes. She goes, the place where they make the butter? And I was like, no, that's the first thing everyone asks, I'm sure. Yep. Like, nope.
Yep.
But John Cena's there.
Yeah. Right? Yeah. You see him quite regularly in his exotic cars. Bright green Lamborghini. You can't miss him. Well, that's one of many cars.
For his vehicle when it's driving by.
Yeah, it was funny because when I first moved here, I didn't realize he lived here. And I was just at the 7-Eleven getting a Red Bull or something. And I walked up to pay for it. And standing directly in front of me is this like mountain of a man, just ridiculously tall. And I kind of see the profile a little bit. I'm like, man, that looks a lot like John Cena. And he turns around and I'm like, because it freaking is John Cena.
That's too funny.
Yeah.
Oh man.
There we go. And we're back. And I don't know whether anybody's still out there, but it was kind of cute. I had just turned.
An erroneous section there. Okay.
Oh, weird. Somebody just went by on a skateboard, and that's.
Oh.
And it didn't show the person on the skateboard. Because I've got the window here, I can see. But,
there's a kid. I see a kid on the corner there. Oh, there he is. It can detect the skateboard, I believe. So I wonder if you'll get one of these that blew my mind. I saw a does it do skateboard? I mean, yeah, skateboard is included. One of the craziest ones I've ever seen.
Now it's getting the group of 3 cars.
That's what I'm saying. It depends on time of day and training these. And remember, we're using the tiny model. It would be totally different if we were using the heavier lifting stuff. But I blew my mind. A kid was riding by on a bike, and I saw the thing draw the box around the bike, and it drew the box around the kid.
Oh wow! Is that the normal one or is that the tiny?
That was with the normal one. Yeah. It's one of those things like once you go to the Jetson line, it's I built a lot of stuff for Nano mainly because it's easier to cater to people because the price point, but that Xavier stuff, I might have to ship you one, Erik. I might have to when this is all.
Oh, you can't see it. Hold on.
On that note, I do have to jump to a meeting. This has been fun, though. This has been super cool.
The girls were going by on the car, and so I just moved the camera manually. I don't know whether it sees anything. I was trying to log into the actual device settings to rotate it, but it's lagging.
So your homework assignment for tomorrow is set this thing up, and maybe even set it to do both cameras. Because remember, you can modify the settings to do 2 video inputs.
Oh yeah.
It's a little complex, and you have to modify the OSD and stuff like that. Ping me if you need help with that, and then we can get them set up somewhere. Because we're gonna be looking at the data tomorrow. So that's your homework assignment. Is just figure out where you want to point this thing, how you want to configure it.
Oh, let me fix that.
Oh yeah. Well, hey Erik, I do have to jump. I'm gonna be late.
All right. So okay, but yeah, I heard you. So you gotta end for today, but we will be continuing this tomorrow.
That's right. So we'll dive into stream analytics and time series insights using DeepStream object detection data. So
Sweet.
pumping bits to Azure.
And what time is that one? That one's a little earlier tomorrow, I think, right?
Yes, that one will be, I'm going off of CST here. That will be, oh, I have a little buffer between my meeting. I got 15 minutes. That one will be at, let's see, 12:30 CST tomorrow. 12:30 Central Time in the afternoon.
Okay, perfect.
So make sure you get some rest. Seriously, I know oftentimes when I was introduced to this stuff, I messed with it until I couldn't anymore. So
Yeah, I was trying to like see whether I could get this, power wheel going by to figure out whether it detects it and what it says, but the sidewalk is like just below. It'd probably take a little bit of tweaking.
driving by in a power wheel.
Yeah, I want to see whether it says car.
I love it. I love it. Well, all right, my friend. It has been a pleasure again, and thank you for all the viewers out there.
Always fun. So look forward to continuing this tomorrow, and then everybody else who's on, feel free to join us at 12:30 Central, where we will continue this, and then we're going to do another stream on Friday to try to wrap it all up.
That's right. That's right. So yeah, we'll get your. I'll help you offline if you need help getting that second camera in the deep stream, and we'll go from there. Sounds fun.
Awesome. Bye, everybody.
All right. Bye, everyone.